Hey guys, welcome to Linked Lists in 10 Minutes by Rebel Guru. In this series of videos, we'll walk you through the basic concepts of linked lists, leading into advanced concepts, and finally we'll also implement a linked list in Java. So let's start with a simple question. What is a list? The dictionary defines it as a number of connected items or names written or printed consecutively. We use lists every day: to-do list, shopping list, invitation lists. You get the point. Okay, that was the English definition. So what is a list in computer science? A list is a data structure that's best described by its properties and behavior. What are the properties of a list? A list is an ordered collection of values where a value may occur more than once. There are a couple of important phrases in there. The first is ordered collection, which means that the order in which you put things in the list is important. So 1, 2, 3 and 3, 2, 1 are different lists. And the second is that a value may occur more than once, which means duplicate values are allowed. So these are the two things that distinguish a list from a set. Now that we know the properties of a list, let's move on to the behavior. So, what does a list do? At a minimum, a list must be able to add an element, remove an element, find an element. In addition, you can concatenate two lists, add a bunch of items at once, and so on. Alright, so we're done with definitions. Let's jump into linked lists. So, how are lists implemented in computers? You can use either arrays or linked lists. Arrays are easy to implement. You allocate a block of memory and get it to behave like a list. As you can see in the diagram, this is an array of 50 strings that are stored in contiguous memory locations. So, why have linked lists at all? Because simple arrays have two major disadvantages. The first problem with arrays happens when you need to insert an item at a specific location in the array. As you can see in this example of an alphabetically sorted list, the entry for ball must be inserted after apple and before cherry. This means that all the elements from cherry onwards need to be shifted down by 1 to create space for ball. This is an expensive operation, and you don't want to be doing it each time you insert an item. The second disadvantage of using an array is that the size of the array is fixed when you create it. If the array happens to be full when a new element comes along, it has nowhere to go. On the other hand, if you allocate too much space and utilize too little, it's a waste of memory. And that is where linked lists come into the picture. Okay, back to definitions. What is a linked list? A linked list is a sequence of nodes such that each node contains a reference or a link to the next node in the list. Yeah, that sounds more complicated than it is. All that it means is that every element in the list, also called a node, has two parts. One part contains data, another part contains a reference. As you can see in the animation, the data part of a node, which we've called info, could be anything such as a string or an object or an integer. And the reference part, which we've called next, contains some memory address pointing to the next node in the list. So how is a linked list constructed? Well, you start with one node. When a new node comes along, you update the reference part of the first node to point to the memory address of the second node, and now you have a list of two. When the third element comes along, you must update the reference part of the second node to point to the memory address of the third node, and so on. But then, how do we know where the list begins and ends? Usually, to determine where the list ends, we use a special value called null. The reference part of the last node in the list always points to null, and that's how we know that we've reached the end of the list. To determine where the list starts, there is an external reference to the beginning of the list, and it is usually called head. This always points to the first node in the list. Okay, so we know how to create a linked list. Next, let's see how linked lists deal with the problems that we saw with arrays. First, the memory allocation issues. What happens when you want to add a new element to a linked list? Let's use our favorite alphabetically sorted list for this example. Cat must be inserted between ball and dog, so how do we do it? The first step is to get ourselves a pointer so we can traverse the list. I know the word pointer sounds scary, but it's just an innocent little thing that points to a node. Let's call that pointer P and point it to the beginning of the list by saying P equal to head. Next, let's move P along the list by using the next field until we get to the node holding ball. Once we're here, we must do two things. The next pointer of cat must point to dog, and the next pointer of ball must point to cat. Remember, the order in which you do this is important. If you change the next pointer of ball before you've updated the next pointer of cat, then you lost the reference to dog, and effectively you've gone and broken the list. Okay, so that was easy. Next, let's learn how to delete a node from a linked list. Suppose we want to delete the node cat from our list. First, we must get a pointer to move to the node immediately before cat, in this case ball. Next, we get ball to point to dog instead of cat, and we are done. How do we do this? We use the next field of cat to get the memory address of dog, and then we update the next field of ball to point to this address. So now, cat has nothing pointing to it. That's it. Because we're doing linked lists in 10 minutes, we haven't gone into details of implementation. But if you're coding it up, always remember the basic rules. Did you create any memory leaks? Did you take care of the edge cases? And do you have all your null checks in place? A null pointer exception is extremely painful and you don't want it. Thanks for watching part 1 of Linked Lists in 10 minutes by Rebel Guru. If you like this video, visit us at www.facebook.com/rebelguru and give us a like.